In other words, tell you what's going to be on the quiz?
Yeah.
Do I ever do that?
You do that for tests.
Do I ever do that?
You give us like a topic.
Really? I give you like topics before you take the quiz? You mean like Quiz Friday, the mole, formula mass, molar conversions? You mean like topics for like the... Really? Because this is the thing that was on the board yesterday.
Is that in Google Classroom?
Yes. Okay.
We're not able to get into those. We don't have access to the.
Okay, then I will change your access to them. Nope, sorry. Google Classroom.
Is the quiz on the computer? Is the quiz on the computer or
Nope.
paper?
Paper.
Okay.
Paper.
Why would it be?
I will change. What happened here?
That would be too much typing for me. I give up.
Yeah,
Do
that's
stupid,
See?
like,
just about.
Exactly.
I see exactly what.
It's not on there.
You're right, it isn't, but you didn't look for it, so you didn't know it wasn't on there. There was the file on there. You didn't realize it was the wrong file until now, so it was on there. You just didn't realize it was the wrong thing. But okay, I'll take the heat for it. I'll take the blame.
It's because you're always to blame.
I understand that. I'm married. I'm used to that. Trust me. Trust me.
Do we have access to your lesson plans or if you don't have like the slides?
I will get you access to the slides.
It's always
Vinny.
Literally what?
Literally hurry.
I'm working on it, but I'm correcting this for Cynthia because she had to have this corrected first. There we go. All right. Save. And you're right. You won't have access to it, but I will give you access to them. Sorry. Okay. So now that I proved Cynthia wrong, other questions? I will try. Oh, good. Sharing there. Good, 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 good. Video's going. Oh, lefty. Okay. Today, ladies and gentlemen, we're going to talk about two-step conversions. We're going to give you some time on the worksheet packet, and then I will give you at least a half an hour to complete your quiz. It's only 4 questions. What's that?
Your questions of the day are so boring. They were so good last try.
I know,
And
but
then you just like,
here's the thing. Honest to goodness, the reason that they haven't been good this week is because some of you had the class last trimester. Some of you did not. So instead, I spent time reviewing binary ionic, ternary ionic, binary acids, ternary acids, covalent compounds. Why? Because some of you who had me last trimester still needed that because you can't write sodium hydroxide. But I'm not pointing you out, Cynthia. I'm just saying that loudly so that it is emphasis in class. Okay? Why? Because I'm telling you right now, this is the basis for what you are going to do in Unit 7. And again, if you can't write formulas from Unit 3, you're not going to be able to do Unit 7 problems at all. At all. Okay? So keep that in mind, ladies and gentlemen. Second thing to keep in mind, ladies and gentlemen, is that in the notes that we gave you, I expanded what was in the notes. This is in the presented notes. It's not in your student notes. But this is the important part for what we are going to be doing today and from here forward. We need to be able to take and get out of mass, out of volume, and out of particles and into the mole. Why? Because the mole can take us wherever we want to go, ladies and gentlemen. You'll notice the mole is the center here. It is the central unit for chemistry. You have to be able to get into and out of the moles to do things. Yes, Ava.
So, what about, like, I saw on that one slide, and Cynthia was showing this to me. Don't call her out because I said that.
Okay.
But it says something about, like, 2 atoms, N equals 1 molecule. What about, like, the atoms and molecules?
Okay. Well, that comes here to this particles.
Okay.
The particle is the smallest piece of matter of that substance. Now, a car is made up of 4 tires.
Oh, God. Don't
Just
talk about
listen. Just stay with me. there are 4 tires, there's 1 engine, there are doors, there are windows, there are all these parts that go into this one thing, correct?
Yeah.
But you can't take your tires and drive them down the road without the car. So the smallest complete thing is the car, but it is made up of tinier things. Okay? This N2 is a molecule. Okay?
Wait, so does 2 atoms
Hold
always
on.
equal 1
No,
molecule?
nope, that's what I'm getting to.
Alright.
This is, listen, let me finish, please. Then you can ask a question. This is a molecule. It is 2 atoms covalently bonded together. One of these molecules would equal 2 atoms. Okay?
Always?
Well, for this particular one, yes.
Oh.
Okay.
So if it's different,
Now,
tell us.
hang on. I'm getting there. Please just give me a second. If it were iron, this is already an atom. So the smallest particle that makes that up is an atom. Okay? So your particles could be a molecule. Your particles could be an atom. Your particles could be a formula unit. Ca3PO4 2. This is a formula unit. Why? Because this is an ionic compound. It is between a metal and a nonmetal. You cannot call an ionic compound in chemistry a molecule. It is not. It is a formula unit. Now, on a test, on a quiz, if you accidentally label this as a molecule, I am not going to mark it wrong. Okay? But understand, we technically cannot or should not call it a molecule. Now, this molecule had 2 atoms. This formula unit has how many atoms? Give me a number.
3.
No, come on, look at it.
6.
How'd you get 6?
I don't know, 3 times 2.
Why did you do 3 times 2 though?
I don't know.
Okay, let me ask you this. How many calciums here?
3.
How many phosphorus?
2.
How many oxygens?
8.
3 plus 2 plus 8.
5 plus 8.
13.
How many atoms here?
13.
13 atoms.
Okay.
There are 13 atoms in this one formula unit. So you could go from moles to particles to atoms for any one of these 3. The difference is this is a molecule, so your particle is going to be a molecule. This is an atom, your particle will be an atom. This is a formula unit, your particle will be a formula unit. But then we can go from formula units to atoms. We can go from molecules to atoms. Okay? You could even be asked, well, how many calcium atoms would be in this? How many calcium atoms are in this?
3.
So that would be 3 calcium atoms is equal to 1 Fu. Formula unit, nothing other than that. Questions? 2 phosphorus atoms are in that 1 Fu. We could break it down any way we want to. 8 oxygen atoms are in this 1 Fu. Okay? It all depends on what they're asking you for. Now, if I did not already answer your question, and if you did not forget it, which I hope you didn't, please ask.
Will you tell us on the test
Will I tell you what on the test?
how many atoms?
No, you should know it by looking at the
What
formula.
about conversion?
What do you mean?
I don't know.
I'm not going to give you the 6.02 times 10 to the 23rd. I'm not going to give you the 22.4 liters. You can write that on your periodic table if you cannot remember those. Is that what you're asking or no? Okay. Sophia.
On the worksheet, you put nitrogen gas, but then you have it as N2. How do you get that?
Well, because if you remember on your periodic table, we had you write the 7 diatomics on the bottom. Nitrogen is, when it is alone as a gas, it will be N2. That is its formula always. Nitrogen will never be alone. That's why we had you add those to the bottom of your periodic table as the 7 diatomics. Okay? Those 7 elements, hang on, down at the bottom here, will never occur as H. Iron occurs as Fe. Aluminum, Al.
So if it's not one of them,
If it's not one of them, it is just the symbol for the element. But if it's one of these 7, they will never occur as just H, just O, just N. They will be H2, N2, O2, F2, Cl2, Br2, and I2. That is the way they will always be. Okay? Always be that way. They will never be alone. Now, again, if oxygen is with something else, there could be 1 of them, 2 of them, 3 of them, however many. That's fine. That's by balancing off charges. This is only when they are alone do they appear this way. Okay? So think about this. If we talk about how many grams of nitrogen gas, and you use the formula as just N, guess what? You're not going to get the correct number of grams because you didn't have the correct formula mass. Questions?
So when you're doing that,
When you're doing that,
when you're doing the diatomic molecules, when you're finding the mass,
formula mass
would you do the mass of nitrogen
times 2.
Okay.
Please remember,
Because
formula mass is always determined by the formula. The formula is N2. Nitrogen is 14.01. Since there are 2 of them here, that's 14.01 times 2. However many are in your formula when you write it, that is what you have to multiply it by. Which is why it is ultimately important to get the correct formula. Okay?
Will you tell me if I got the wrong formula on the test?
Yeah, after I grade it, yes.
Wait, what question is
This isn't. This is just us talking.
She was talking about.
I don't know. Would
5.
yeah.
For multiplication?
Okay.
Like which one is greater than the other?
questions?
For number 7, does this N part mean anything? The 0 degrees?
The 0 degrees Celsius, the 760 millimeters of mercury, 101.3 kPa, 14.7 psi, or 1.00 atmosphere is telling you STP.
Don't do anything
So
with
if
it.
you don't do anything with it, it's just telling you that gas is at STP so that we can say this is true. 1 mole equals 22.4 liters. That has to be at STP. I will give you STP. If you get anything with temperatures, anything with pressures, it's telling you STP. Ignore that. But I have to put it in the question. Otherwise, this relationship is not true. Okay? Yes.
Are the 7 diatomic molecules always are they always going to be gases in the?
Most of the time, yes, because if you look at them on the periodic table,
They're all
hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, bromine and iodine could be liquids or could be solids. Normally they are appearing as gases, but even if they're a solid, it's going to be Br2. Even if they're a gas, it doesn't matter what state they're in. When they're alone, they're always that way. Okay? Good questions. Any others?
If you put molecules on that, is that the same thing as the particles, or do we have to convert
Molecules is the same thing as particles, but particles cover all 3 of these. They cover whether we are talking about something like this, which would be a molecule, something like this, which would be an atom, or something like this, which would be a formula unit.
What if it wants us to is it ever going to ask for it in atoms or?
It can, and what I'm telling you, and I'll show you this in a minute, we get to formula units, we get to molecules, and then we use one more step. What we're doing is we're trying to show you a method that you can use. What I mean by that is these two are equal to each other, correct? So we can make a conversion factor out of it. We can put two atoms on the top, one molecule on the bottom. Or I could put one molecule on the top, two. Anytime two things are equal, we can use it as a conversion factor. And that is what I'm hoping you're going to start seeing. We use this conversion factor to get from grams to moles. We could then use another one to get from moles to liters. Because maybe it says you have 12.5 grams of nitrogen gas. How many liters do you have at STP? Take the grams, get it into moles. Take the moles, get it into liters. That's also why we call the mole the central unit. We get it into moles, we can go wherever we want. It could say you have 12.5 grams of this. How many atoms of it do you have? You can do that. Why? Because all we're doing is linking facts that we know together to get from where we start to where we end. Okay? And I will show you that right now, unless you have another question.
For number 9, it has like the 2.88 times 10 to the 21. Do you put that in the math, or do you just do the 2.88?
Which worksheet are we talking about?
The mole conversion, number 9.
Okay, let's see. This one?
Yeah.
Okay. So, to do this one, ladies and gentlemen, we'll go through it real quick here because it's not bad for reviewing before we get into what we want to do today. First of all, you always start out with the number that's given to you in the problem, 2.88 times 10 to the 21st molecules. Now, I want to go to moles from molecules. The relationship between mole and molecule is this. 1 mole equals 6.02 times 10 to the 23rd molecules. Okay? Now my substance is N2O5. On today's quiz, you get a point just for writing down the substance's formula. You may not need it. I don't need the formula here to do this problem. It's not involving mass. It is involving this. So I'm going to take this and I'm, bless you, going to make a conversion factor out of it. Part is going to go on top, part is going to go on the bottom. Which part goes where and why? Okay.
Molecules on the bottom.
Thank you. And again, I think we got the same thing. We just said it 12 times over each other. 1 mole goes on the top. 6.02 times 10 to the 23rd molecules goes on the bottom. Now, you can abbreviate molecules. Just don't do it MOL. You got to go at least MOLEC. I am not going to take off if you don't have the units here. You probably need the units to know how they're set up. But the only place I'm grading you on units is in your final answer. Molecules and molecules cancel. Now, in your calculator, you're going to take 2.88 times 10 to the 21st. Is there anyone who wants me to show you how to put that into your calculator again? You're going to divide it by 6.02 e to the 23rd. Why am I dividing it by it? Why? Because it's on the bottom of the fraction. I don't have to worry about doing anything with ones. But ultimately, the way we handle any fraction is we multiply by the number on the top and we divide by the number on the bottom. If the number on the top is a 1, you won't hear me say, well, multiply by 1 and then divide by this. Just going to say divide by this. If this were flipped over, I would say multiply by this. Don't worry about dividing by 1. Do we understand that? So now you hit that in your calculator. And for an answer, I get 0.004784. I'm going to stop at the 8 because there are 3 sig figs in this number. There are now 3 sig figs in my answer, and my unit is the only thing not canceled out, mole.
I thought zeros after the decimal.
Nope. Zeros at the beginning of a number, which is where these are never significant.
Even with the decimal.
Even with the decimal. Zeros at the end need the decimal to be significant. But zeros at the beginning, these are called leading zeros. They are never significant. They are simply placeholders. Okay? That is what they are there for. Zeros in the middle, yes. Zeros at the end, if there is a decimal shown. Zeros at the beginning, never. Questions? Yes, no, maybe so.
No.
Okay. Then here we go, ladies and gentlemen. Okay, you asked for it. Here's the question. How many atoms are in 2.65 liters of nitrogen gas at STP? So, we are going to begin with 2.65 liters. I do need the formula, nitrogen gas, only because I give you a point for it. And because I'm going to need to figure out how many atoms here. Now, the first thing I'm going to do is take it from liters and get it into what unit? How? Okay, 1 mole equals 22.4 liters. We'll determine which goes on top and bottom in just a minute. But this will take us from liters to moles, correct? Okay, next, to get to atoms, I need to get to what? Mass or particles? Particles, which is 1 mole equals, I'm going to change color because I get the feeling I'm going to run off of the gray here in a second. 6.02 times 10 to the 23rd. All right, nitrogen gas, N2. Atom or molecule? N2. Molecule. N2 is a molecule. It's called a diatomic molecule. So the particles are molecules. But I want to get to atoms. So in this one molecule, there are 2 atoms. I have everything I need now to do this problem. And the only thing that I haven't given you previously is this one right here. Until today, when we started talking about it, I hadn't given you that one, right? So, all right. Our first one has to involve liters. That's this one here. What goes where?
Liters on the bottom.
Good, liters on the bottom. Why? Only way our units will cancel. 1 mole on top. Liters and liters have now canceled. I'm not done though. Which one do I do next? Which one involves mole? Mole to molecules here. What goes where?
More bottom.
1 mole on the bottom. This is why it's called unit cancellation, ladies and gentlemen. We are letting the problem tell us what to do. The only way to get rid of liters is it's got to be on the bottom here. And these have to be equal. The only way we get rid of moles is if it's on the bottom here. And what I'm going to put on the top has to be equal to 1 mole. So that is 6.02 times 10 to the 23rd. Molecules. Okay. If I stopped there, I would be in molecules. If I wanted particles, I would have stopped there. But it actually wants specifically atoms, right? So now what do we do?
Put the molecule on the bottom, 2 atoms on the top.
1 molecule on the bottom, 2 atoms on the top.
Can we calculate it through every step, or do we have to put it like this?
Okay, here's what I will tell you. It is completely and totally your choice. If you want to stop at each one, get an answer, and then move on, your choice. I don't care. But here is what I will tell you that happens to students sometimes. When you decide to stop after one step, you're going to write down your answer, correct? And then you're going to do the next step. And then you're going to write down your answer. And then you're going to do the last step, and you're going to write down your answer. And as long as you write down your answer correctly, you will not have a problem. But what I've seen is people will get an answer, they will go to write it down before the next step, and they'll change numbers around on it. I don't want that to happen. So when I do this, I'm going to put this all into my calculator at once, one time, and hit equals. Because then if I did make a mistake with the number 2, I go back to this one calculation. So I am literally going to take all the numbers that are on top, 2.65, 6.02 times 10 to the 23rd, and 2, and I'm going to multiply them together all at once. So in my calculator, I'm going to do 2.65 times 6.02 second EE23 times 2. And I'm not going to hit enter yet because I'm going to divide by the numbers on the bottom. Now, how many numbers are on the bottom that I need to put in my calculator? Just the 22.4, just the 1. So I do not need parentheses or anything like that because I'm only dividing by one number. I put divided by 22.4, I hit enter. If you did it correctly, you should come up with 1.424 times 10 to the 23rd. That is the number that you should have gotten out of your calculator. And we should not be any different because we didn't use formula math. We didn't round anything. That should be the number that you get out of your calculator. I will write it down. The number that I got, 1.424, so I'm going to leave this as 1.42 times 10 to the 23rd, and the unit is atoms because that's the only thing left that we have not canceled out.
Wait, how come I got the right answer, but my power's not 20?
Okay, so let me ask you, how did you put in 6.02 times 10 to the 23rd? What's your power? 24 or 22?
For what?
What was your power for your answer? 24. You put in 6.02 times 10 EE23.
Oh, yeah.
Okay, told you to be cautious of that. The EE button takes the place of the times 10. What you did was told it to multiply by 10 and then take it to the 23rd power. You don't have to do that. The EE button takes the place of the times 10. Okay? But again, if you hadn't done that now, you wouldn't know it on the test. You would get your answer wrong. Sophia.
So I was looking at the answer key, and for the last one, it's the same. It's almost the exact same thing as this, but you put 17 atoms above 1 mole.
Okay, what was the compound?
Aluminum sulfate.
Okay, so aluminum sulfate, Al2SO4 3 for a compound, correct? So this is 2, this is 3, this is 12. Last time I checked, if we add all of those together, we get 17 atoms.
Oh.
Okay?
So no matter what, it's always going to equal 1 molecule?
Correct. Or one formula unit. What?
A ring.
A ring? I have not seen one. Anybody see a ring laying around? Right by you, Mitzi or Lizeth?
I don't remember if I left it at home or if I brought it. Oh my god.
Anybody? Ring?
Promise ring.
What was the promise that you just broke?
Nadia. Bro, Cynthia, don't tell Alex.
If we find it, I will hold on to it for you for class today.
Okay, thank you.
Okay? Young love dies in chemistry. Questions?
Wait, okay, so then, how do we find the How many atoms are 150.0 grams?
Okay, if we started out with 150 grams, we would change this, the number at the start, to 150 grams. What would this conversion involve? Formula mass in 1 mole. And then everything else afterwards would go the same way.
So we can find the formula mass.
Well, you're going to have to, because the only way to get out of grams and into moles is to use formula mass. Okay?
Why do you put the atoms above the mole?
Atoms above molecule, because this unit comes out in
This
molecule.
one you put it above the mole.
I'm sorry, then I didn't go far enough. It should have been over molecule. Unless, what was the substance?
Yeah, aluminum.
Then I just didn't finish writing out molecule. Sorry. I didn't finish writing out molecule. Okay. Questions? Okay. You have got about 8 minutes. I'll give you a half an hour for the quiz. We get out of here at 22. So at 10 minutes till we will start the quiz. Right now you've got 8 minutes to ask questions, to make sure you've got everything you want on your periodic table, and then we will begin the quiz. Yes, Cynthia. I can. Hold on 1 second. I want to stop the video that I'm making for my next hour.